Okay, I've got the skateboard motor as a generator here, and this is a pulley around it. It has a few wires coming. We've got 3 larger wires that are from the phase windings, and then we've got 5 smaller wires that are from the Hall effect sensors. So I've got an oscilloscope hooked across one of the phase windings, and then I've also got this is being used as a 5-volt power supply right now. I wanted to read a signal into this Arduino. I have to put a transistor to level shift. This can only take 3.3 volt inputs, and this is a 5-volt signal, so I've got to do some level shifting here. So I don't have that hooked up right now. It's just an interface to the power supply. This is providing 5 volts to the Hall effect sensors, and one of the sensor signals comes out, and we've got a pull down resistor, or a pull up resistor, 4.7K, and that's what I'm reading from the oscilloscope. So we're getting 2 signals on the oscilloscope. One is the phase we're coming off from the generator here, and then this more squared off wave is the Hall effect sensor. And you'll notice that the transitions from this Hall effect sensor aren't exactly at the 0 crossing. I was hoping it would be, so that I could maybe use it as to drive a rectifier or MOSFET rectifier, but it doesn't quite line up. And I tried the other Hall effects too, and they don't quite line up with a 0 crossing. But I can probably use that for RPM sensing though. Okay, I've got a string wrapped around the pulley, and I'm going to try to pull it with as constant a speed as I can. Here we go. Well, that wasn't so constant, but let's see what we got here. If we zoom in, try to find some place that's fairly consistent. Right about there. Okay, we're looking at 17.8 volts peak to peak, and we've got a frequency of 86.8 hertz. So that's going to be up around the maybe 500 RPM range. So that's pretty fast, but that's the kind of signal we're looking at. So using the information we just got, we've got a peak-to-peak voltage of 17.8 volts at a frequency of 86.8 hertz. So if we convert that to RPM, 86.8 cycles per second, I counted 10 cycles per revolution, and then convert it to minutes, so we get 521 RPM. Our peak voltage is just half the peak-to-peak voltage, so we get 8.9 volts. Take the ratio 8.9 to 521, we get 0.017 volts per RPM. So if, like at a cut-in speed of around 100 RPM, we're looking at a peak voltage of only 1.7 volts, which isn't a whole lot, so we've got to do something about that, I think. The resistance between the stator wires here is about 1.4 to 1.5 ohms. Okay, I took this cap off, where those 3 screws came off, and this cap from here came off fairly easily. And then this urethane came off, and I guess that's so that you can replace the urethane easily. Then the back cap had 6 screws, and I used a bearing puller to pull that off. So I stuck a couple washers in there and stuck this into the bearing puller in there and just cranked on that, and it pulled this bearing off. So this would be towards the outside, this is on the inside of the bearing, and hopefully I didn't damage anything. Still feels smooth. Okay, so this is what we're looking at on the inside. Got our magnets, and we got our coils and the Hall effect sensors. So we'll see what we can pull out there. Alright, the center part pushed out fairly easily. So that's the magnets out there. Here's the stator. Its windings and electronics. Okay. Let's get a good look at that. I don't know if you can see this, but there's a group of wires that's apparently attached together and they put a sleeve around it and then crammed it into the slot. So I'm guessing that this is a Y configuration as opposed to a delta. So I think that's where all the ends of the phases got connected together. There's the little Hall effects. We've got a slot in the laminations here for the Hall effect sensors. There are two. So if I'm going to rewire this, I think what I'm going to have to do is pull this bearing off and I think these Hall effects will just slide out. I don't think those are glued in, but maybe if I push on the center, I can just push the center shaft out of the laminations. So we'll see how that goes. This bearing is, I pried this bearing off from the shaft using a screwdriver. I may have done a little bit of damage to some of these wires, but we're going to be replacing them anyway. I'm trying to do as little violence to this as I can. Okay, I was able to push this out with a bearing puller. It's the central shaft that was going in here, and it has a little slot on the side, and that's where this pin was, and that pin mates with a slot in the laminations. So I just have to make sure that's put back when I put it all together. There are 20 magnets here, and there are 18 slots, I guess you'd call them, on this stator. There doesn't appear to be any screws holding the circuit board on, and I'm able to just sort of gently pry these Hall effects out of the slot. So my guess is they put this board on, and then they put the phase windings next to it, and then just drop this long sleeve over it, make sure it's in place, and then just shrink that down. So I think in order to disassemble this, I'm going to have to cut off this shrink tubing here. Alright, the shrink tubing is off, and sure enough, the Hall effect sensors just come right off, and we're left with the phase windings here. Each winding appears to be made of 5 strands of what I measured to be 0.3 millimeter diameter wire.